Remember? I only saw one handshake, yeah. 2, 3, 4. Good deal. Okay, third of the class remembers. Now look what we get right here. I got a prefrontal to my frontal. Just saying. Okay. But look what it helped me do. Because me getting up out of that chair to stand up was motivation, and it was initiation, and it was the thought about it. So these areas of the brain, they're kind of cool, okay? So if we look at now topography of the motor, don't forget precentral, okay? So we'll look at me this way, all right? Because if I think about my central sulcus going like this, all right? Remember, my sensory was post, my motor is pre, okay? Once again, I got my little homunculus man, all right? And, do y'all notice anything?
Sticking his tongue out.
He's sticking. Yes, true. I don't think I can do that. But do you notice how, once again, upside down, certain areas of the brain have a bigger portion than the others, and very similar to what we saw for sensory. Because, once again, for control, it's got to be more fine-tuned here than here. This needs more fine-tuning. So these areas where if I've got my sulcus, and I've got post and I've got pre, all right, they're giving us this association, this intake of the sensory information, and then we're getting that ability to think or create that response and carry out that response from the motor. So we begin to see that having this ability is how we're going to integrate some of this information. And if we're dealing with the somatic, meaning this part of the body, we're looking at it controlling the voluntary movements. Is that correct? Now, what we do, okay, we need to make sure that we can maintain our posture, that we can do movement that is needed. Now, remember our reflexes? We didn't have the conscious control, okay? But even though we didn't have conscious control, for a lot of what we do for the reflexes, we still maintained our posture and our ability to move limbs and stuff, right? Now this voluntary portion, where we're looking at these areas that exist, and I mentioned those upper motor neurons, okay? Those upper motor neurons will, have their connection to lower. It's going to be the lower ones that exit out of that vertebral column. They're going to go by way of that peripheral nervous system to skeletal muscle. Do you guys remember that? Saw a couple of heads shake. Do you remember the peripheral nervous system, the one that exits the vertebral column and goes everywhere else? Okay. Their cell bodies for the lower, they're going to be in the anterior horn of the spinal cord and in cranial nerve nuclei of the brain stem. Y'all had 12 cranial nerves? Yes? Do you remember anterior horn? The horns, the gray matter. Exactly. Okay, good deal. So, for it to be voluntary, I tried to represent how I began to think about the movement, which means I would stimulate those upper motor neurons. If I stimulated those upper motor neurons, that information, because it's motor information, it has to travel down the spinal cord, okay? If it goes to lower motor neurons and it can move or synapse with something that's going to leave, all right, we stimulate the skeletal muscles. So therefore, my abilities of my brain, by using my nuclei and the cerebellum, beginning to think about it, beginning to have the stimulus, beginning to plan, beginning to execute it, okay? I did that in conjunction with those areas of my brain, with my spinal cord, to my skeletal muscles. And it was all voluntary. The information that we looked at for carrying out that movement, it went by way of the motor nerve tracts. Do you guys remember the tracts? Okay, and those tracts are ascending or descending. Motor information is descending. Sensory information is ascending, okay, going up. The information that we get for this motor activity, for something to occur, it can travel by way of either a direct or an indirect pathway. For a direct pathway, this is important for maintaining muscle tone. I just said a few minutes ago, because my muscles had tone. Did I not? Did I say that? I think I did. What did I mean by muscle tone, if you guys remember from A&P1?
They're like always contracting?
Not that they're always contracting, but they have that little bit of the charge across their plasma membrane so that they're ready to contract. If they didn't have any of that muscle tone, any of that electricity, and I had my thought about standing up, okay, and I was planning that execution of it, meaning I'm stimulating my upper neurons to my lower neurons, to my skeleton, to my muscles that are going to need it. But if they didn't keep any type of tone, I would be like this. Because it would have to start all the way with nothing, right? How did it keep the tone? Do you remember? What channel was it in the plasma membrane that allowed there to be a little bit of electricity? That potassium channel, the leak channel. Right. It just stayed open all the time. allowing that little bit of passage to cross. So I had to have a direct pathway to help me maintain that muscle tone. Now, the indirect pathway, for example, if I'm just walking across the floor right here, where my movements really don't need to be precise, okay, and I'm just taking a casual stroll, well, that doesn't have to be a direct pathway from here to here, okay? It can have a pathway where it's going to go ching, ching, boom, an indirect pathway. So what does that tell me? Okay? Do you guys remember when you look at the anatomy of the spinal cord? It had those ridges, okay? And one of the things that I mentioned was the pyramid based on the structure, okay? So, direct is considered pyramidal, meaning by direct way of the pyramids. You remember in some areas of the brain we talked about the pyramid, okay? Indirect is extra pyramidal, outside of the pyramids. So if we look at our structure of the spinal cord, y'all remember the gray matter, white matter? We had our dorsal, ventral, lateral, and then all of them had these tracts in it, okay? Notice my direct pathway is in the pyramid. That little projection that stuck out. But look at my indirect pathways. My indirect pathways are all over the place. They're outside of the pyramid. Does that make sense? In terms of the information, there you go. Since we've been talking about sleep and everything, is that not the making of a nightmare? But now look, it's rather simple, okay? Notice that they're trying to tell me this line right here is a direct pathway. It went straight from those upper motor neurons, okay, that are found in the cerebral cortex, and it went straight to a segment of my spinal cord that led directly to a muscle. Yes, no, maybe? So this right here is what was needed. That is what was found in the pyramid. A direct pathway, now here's the thing that can kind of drive you crazy, because they give names to these pathways. Do not get caught up too much in the name. Understand the name. Corticobulbar. Your prefix tells you the origin of that pathway. The suffix